view
Control
for
L. Control large.
Okay, we're recording now.
okay.
Thank you guys for convening. Thank you, buddy.
All right. Well, we're just kind of finishing up the last slide here on the system. It's just a visual about just what we talked about with 65,000 amps. And then as you get into the system, you could maybe have 25,000 amps available at this panel. Maybe it's 100 feet over. 50,000 amps available at this panel. Maybe this is in the same equipment room as this one. Then you got a dry type transformer which steps the voltage down. And dry type transformer may be in the same equipment room. Well, that's only 4,800 volt or amps. Why would there be such a large difference in this lighting panel and this distribution panel if everything is in the same equipment? Higher voltage up here, 40 volts here. Notice I got a dry type transformer there. Maybe that's a 30 kVA transformer. Stepping it down to 208, 120. This is straight 480 with no transformer. So obviously, is this transformer doing anything? Transformer's doing a lot. Transformers, when we talked about it, remember it was the rule of magnetic induction. So your one voltage creating a magnetic field coming out of second voltage. Inherently, there is a lot of built-in impedance. It's very common to have 4 to 5 or even 5.5% impedance in a standard dry type transformer. And just the way these things are constructed, there is a fixed amount of available fault current that can come out of every transformer, and it'll be set to the full load amps in the kVA, or the kVA I should say, in the impedance of that transformer. So usually a dry type transformer that you'd see in a normal 30, 45 kVA, 75 kVA type is going to knock your short circuit down to something in this type of range. So if anybody, if you ever had an application where you need to lower the fault current at a specific point, a good thing to consider is a dry type transformer. Even if it's only a 480 to 480 volt dry type transformer. You're not changing the voltage, but you're taking advantage of the impedance. We'll come back later, I think we may talk about selective coordination. I'll touch on that, and we'll say why this may be a little bit more why it come in handy. But what we're going into now is more the products. So specifically, we'll talk about the panel boards first, and then we'll move into switchboards. And this is information from me as a manufacturer on what I'm looking for in a panel board. So we'll talk about what's a panel board, some of the components in it, some of the applications, and touch on the code stuff. So a panel board, by definition, is a wall-mounted electrical power distribution device for use in commercial and industrial applications. Provides circuit control on off. That's all that is. And overcurrent protection, which is overload or short circuit fault for light, heat, or power circuits. We talk about a panel board, and I think we got one coming in here. A panel board is going to come into 3 components. The first one is the box. The box is nothing but bent sheet steel, and it's a box with all the sides except for the front. So that box will mount on the wall or in the wall. Second part of the panel board is the chassis. The chassis is really everything having to do with the panel board electrically. So you'll get a place where you're going to land your cables, maybe some breakers, some lugs, and a dead front cover that covers the breakers on the front of that. That mounts inside of this box. So when you're doing the installation box, the first thing you secure to the wall. Chassis then secures to the box. Once you're all wired up and all done, the trim then secures to the chassis and the box. And the trim, just by looking at it visually, it is it's an aesthetic device and a safety device. It's going to cover the dead front, the chassis itself. You can see there's a little door in the front of that panel board. When you open that door, you will see this chassis right here. When I say dead front, that means you can walk up and touch everything on it and not get a shock. You're not going to be exposed to live electricity. So in your garage, hopefully you've got some kind of protection on there. But if not, along the edges in the wireways or the gutters is where the cables are. That's where the connections to the breakers are. And that's where the live electricity is that you want to prevent unauthorized people from touching. So 3 types. When you're bringing cables into a panel board, there's 3 types of main devices. And the main device is the first description of a panel board. Am I main lug only? Am I main circuit breaker? Or am I main fusible switch? Lugs, you know, we've got a better picture coming up, but lugs is nothing but your landing lug, your landing cables directly on the bus that the feeder breakers are tapping off for. Main circuit breaker, shown up here, you terminate your incoming cables on this main circuit breaker. This breaker protects everything downstream of it. And fusible switch is in reality the same thing as a circuit breaker, except for it's fusible instead of a circuit breaker.
Can I just
turn
my email off?
Let's just keep bugging.
So what's the difference between the main lug you put your own main in?
The main lug has no protective device. So if you go upstream
For a sub panel?
for sub panel
Okay.
or a value engineering method, if you've got a switchboard on this side of the wall and you've got a panel board on that side of the wall and you're in the same equipment room, and say it's 100 amps, you put a 100 amp circuit breaker here, you're going to need that to protect the wire that feeds up and around over to this panel board. And then you have a choice: do I put main breaker or main lugs? Okay, main breaker, there's a couple things it's going to do. Number one, we talked about it's going to protect overload short circuits. Okay, if I got a 100 amp breaker here and a 100 amp panel board over here, my choices are: do I put a 100 amp main breaker here, or do I save that money because I've got a 100 amp main breaker here, so I'm protected either way. So that shouldn't be a factor. The other thing to consider, which is often the driver, is the convenience of disconnecting the panel. Often you'll see it if I'm this way. If I feed up one floor, my switchboard's here, I'm feeding my panel board up one floor, and I'm an electrician up there, and I need to shut that panel off to add a breaker or work on it for some reason. Then putting a main breaker up there is going to add the extra benefit of, while I'm at the breaker, I can turn things on and off rather than have to come back down here and come back up here. Then you run into the safety factor. If I come back here, open the breaker, I run back upstairs, I go as I'm going into work, my buddy just got off break, he walks into the switchboard and sees this circuit breaker. Why is this breaker open? And lockout, tagouts, procedures, and all this other stuff can come into play. So, I guess the one of the things to consider between main lugs or main breaker is convenience of disconnect.
Todd, just for the same amp, what's the difference? Like if I 225 amp panel, main lugs 225 amp main circuit breaker, percentage was difference in price. Just we're not going to hold you accountable for that.
Yep. It's the number one driver on price is the cost of the circuit breaker, which could literally double in price depending on the rating of the circuit breaker. We talked about it has to be rated to the short circuit available, so each breaker is going to have the AIC rating, or the interrupting rating, labeled on the circuit breaker. So on a 100 amp breaker, that if you throw a dart into the middle, say 35K, you probably are looking at a difference between if you had a 1200 amp panel versus a 700 amp panel, you could be looking at $400 or $500 difference between main breaker and main lug. And if you don't need it for protection, then it's really a redundant, easy access to turn a panel board on and off. Yep.
So, if you have the main lugs, what needs to be upstream of that so you can isolate it?
Good question. You need to have the circuit breaker upstream of that. That would be properly rated for the panel board. And often these are, because the general rule of thumb is a 100 amp breaker is required to feed 100 watt cables, is required to feed a 100 amp panel board. So just by how you're going to have to do it anyway, this breaker, the 100 amp breaker, is going to have to size to be protecting this 100 amp panel. So if you put the 100 amp breaker in there, this breaker here should really be identical to the one you'd have upstream in the switchboard. So maybe that's the way to think about it. Do you want your main breaker in the panel, or do you want your main breaker in the switchboard? Panel boards can be top or bottom fed. If I hang them on the wall, it doesn't matter from a manufacturer which way you want it. However, we need to know that before we build it. A lot of times in a commercial load, or a residential load center, and some other products, a lot of times they're reversible or convertible in the field. But generally speaking, this will be one of the pieces of equipment, because we'll build it with the circuit, with a main breaker especially. We need to know how to build that from the inside. The other thing we're going to be needing as a manufacturer is, how are you going to mount this, surface or flush? On a surface, I've got a wall. I'm taking my panel board can, and I'm basically bolting it to the outside of the wall. You see all the conduits then will be coming out. They'll be running along the wall up into the ceiling. The other option is to flush mount it. When I say flush mount it, really this is what we're talking about. There's a hole in the wall between two studs. If you think about a residential panel, designed to fit between two studs, boxes in the wall, panels in the wall, conduits are in the wall. The only thing on the outside is the trim. And we'll need to know that as a manufacturer to make sure you get the proper trim. Why? Because a surface trim bolts, it's basically just the width of the panel board. That's exactly how wide it is. A flush trim, everything outside of this dotted line is extra. And that's the stuff right along here in the edge. We put it on there so the trim overlaps with the wall, because it looks like that. It's aesthetic. There's a couple of different types of special panel board trims that when you're designing you may want to take into consideration. Two of the most common you'll hear are concealed trim clamps or concealed trims. And notice it just kind of looks like a flat piece of steel. There's nothing that you can see along the edge. Normally you can see, well, you can see trims along the edge. The other thing is a door-in-door, where this is the first door, This is the door on the inside. This is the one that's common. You open that up and all your circuit breakers are behind it. The second door, here's the hinge right here. Second door allows you to open this whole piece. The whole trim swings open, just like the smaller door. Who would benefit from a door-and-door trim? The installer. Exactly. Exactly. Think about a contractor. Nowadays, inspectors are pretty finicky when it comes to safety. I'll say finicky, but I mean they're following. It's pretty safe. They're not as lackadaisical as they used to be. So if you're a contractor and you're installing a panel board, and you've energized that panel board, and it's going to take you a few days or while you're working on it, as you're adding your circuit breaker, wiring your loads up, turning breakers on and off, testing things. Every time you leave that panel, remember all the wiring is done in the gutters here. So every time you leave that panel board is hot. And according to NEC, you need to reinstall this entire trim. Well, if you've got screws that you got to put in, and maybe you've got 8 screws per panel, maybe you can get away with putting in half as many, but it's going to take you 5-10 minutes to put a trim back on so you can walk down to your light, make sure your light works, check your circuit, come back, retake off the trim, do your next breaker, and it can be a very tedious situation. Or say you got to break at noon, you got to break at 10, you got to break at 2, and every time you break, you got to reinstall that, even though you're working in the same equipment. So a contractor, by having a door-and-door trim, it's as simple as opening the door, shutting the door, open the door, shutting the door. Maybe throw 1 screw in. Contractors love door-and-door trims. Cost. Most manufacturers, including us, used to charge probably about $75 just for the door-and-door trim per panel. So there's a good cost associated with it. What Eaton did is something a little different than any of our competition. A few years back, we sell panel boards, thousands and thousands of panel boards, and we looked at the contractor standpoint. We talked to the contractors, and this is how we continuously improve our products. What's wrong with our product? What do you like about our product? Or what in general are some of the things that you want to improve? And we continuously heard there's so many more things you manufacturers can do with the trims and make it easier on us contractors installing these and this and that. So we invested some money, some research, and we came out with something a few years back called the Easy Trim. Now the Easy Trim is it's a laser cut door. It's got the concealed hardware, which is the trim clamps that you can't see. It's got the door-and-door feature, and that's standard. And some of the other standard things for a panel board, the lock on the front. The deal is, it's free. It's no charge. We don't charge extra for it. This is our standard trim. You don't need any tools to install this. Versus a normal trim, you're going to have a couple of bolts, a couple of screwdrivers you're going to need, something to put it on. And it installs in less than 20 seconds with no tools required, no hardware required. So if you're a contractor and you look at which type of panel board you're going to buy, this is one of the things that they're going to consider. Well, if I use the Easy Trim and I got to take my panel off 5 times per day or 10 times per day, and I can save 10 minutes every time I do that, an on-off deal. Contractors think money, so that will be going through his head, and they'll say, well, I'm going to be able to use less labor using the Eaton solution versus manufacturer X, and this is a pretty good deal for them. Quick snapshot just to kind of how it looks like. All we did for the trim is we put these hinges, these notches, here on the on the side of the trim. So when you take the trim off, rather than have to normally, you would have to hold it up, put a screw in, put a screw in, put a screw in, and keep going from there. This one, you hold the trim up, and all you got to do is set this notch on its corresponding elbow, so to speak, on the panel board. Set it there, and then just kind of lift it and move it, and it falls right in place. No tools, no screwing, no nothing. Anybody here contractor or been a contractor?
I used to be out in the field. We used
Okay.
those on a working ram job. Those are nice.
You use the easy trims? Good. And they work for who'd you work with?
At that time it was Gilbert.
Gilbert? And that was better than the old
A
method?
lot better, because those things are so cumbersome too. They're heavy,
Yeah.
and so instead of holding it up, you just it right on.
Yeah, and you know, a lot of times you'll get panel boards that are 36 or 48 inch high, and one person could probably handle those. But many times you'll get 60 inches, 72 inches, 90 inch high panel board trims, and a 90 inch or 72 inch high panel board trim is not even a one-man job. They're so cumbersome to try and get into place. I'll say it's still not probably a one-man job, but it's pretty darn close. So when you get out there, always think about, hey, Eaton's got the easy trim. That'll make my life a little easier.
And Todd also, I always tell the students when we design a system, the expected life is 40 to 50 years. So think of those poor electricians who will maintain the system for the coming 50 years.
Yep.
We were doing in our cafeteria here at Dunwoody, opening a panel, I think it's 200, I think it's 600 amp panel. And when you guys open that panel hot to add the circuit to it, imagine if you go back to that screen, imagine as you open it, the possibility of dropping that door accidentally or one edge of the door right into the hot conductor and get electrocuted. There's always maintenance, always possibility. As you move it, because it's so heavy, one of the edges goes right into the panel to the hot lugs, and you get yourself into an accident. So it's, I like that door that opens and things that minimize the possibility of electrocution for maintenance electrician down the road.
Yep. And this, once you put it on the notch, the door feature, you can basically, you open it on these notches. So you can still open it just like a normal door, like a normal door. So I'd say if the cost allows it in the project, definitely look at easy trim. And if you don't go there, at least consider the door feature from a different manufacturer, because it is a great saver. Multi-section panel boards. Now, a couple years ago, I was coming up here saying NEC had this rule about a 42 circuit limit. It's called lighting and appliance panel board. NEC says no panel board can be more than 42 circuits, branch circuits, except for a few conditions. But when you're talking normal lighting and appliance or lighting and receptacle panel board that is going to feed a commercial building on the inside, NEC removed that restriction, and the rule now is you can put in as many circuits as a manufacturer can build a panel board. And there's some comments and restrictions that we'll touch on. Generally, most people are still following the 42 circuit rule because I think they've realized the 42 circuit rule kind of had a lot of common sense into it. The space required, height-wise, how many cables can I literally fit in a gutter while I'm running out all my loads? How many conduits can I fit into the top? So there are some physical limitations on why it just makes sense. So one of the things that can be done if you've got more than 42 circuits, and it's very common to have 84 circuits, where you've got basically two of these panel boards, but you only need one main breaker or one cable feed to this. So when a panel board connected by one feeder or one cable feed needs to be furnished more than one section or one box, each section must be furnished with the main bus and terminals of the same rating, unless a main breaker or fuse is provided in each structure. So normally when I think multi-section, you're not having that. You're not having main breakers in each structure. That kind of defeats a lot of the purpose. So one feeder into one panel board, which then feeds another panel board and maybe even another panel board. All those panel boards that are multi-section have to carry the same rating. There's two types. There's SubFeed lugs and ThroughFeed lugs are the two methods for connecting these panels. This one takes a while for people to get the concept of. So keep the note handy when you're doing this, difference between SubFeed lugs and ThroughFeed lugs. SubFeed lugs are incoming cables here, main lugs, no main breaker, and basically a double set of lugs because you then jumper to the next panel. If you had another one, you'd have a double set here and jumper to the third panel. Okay, this is just a visual. Normally you're going to have, this is your bus bars, A phase, B phase, C phase, and where we normally may just put one lug to land one cable, we're going to put two. One cable lands here, feeds the panel, the other cable lands here and jumps over to the next panel. Physically where these are located, here's your panel, here's some branch breakers, way on one end, either the top or the bottom. Other than SubFeed lugs, that's probably the most common of the methods is ThroughFeed lugs. ThroughFeed lugs, actually, when your incoming cables are here, you feed one set of lugs here through your bus. On the other side of your bus, you put in another set of lugs, which then jumper over to the second panel. And you could feed all the way through here, put another set of lugs, and feed into this panel. So you're really feeding through everything. Everything is just continuously through panel to panel, up and down. This one, the SubFeed lugs, is available only with main lugs. The reason is the physical requirement to SubFeed lugs. You need two lugs. A circuit breaker is only going to have lugs available that are sized for the circuit breaker. So until you get to a really big size, you're not going to have the option. There's just not physical space to land two sets of cables under a circuit breaker. For ThroughFeed lugs, because you're just landing one cable, you can have the option of having this as main lugs or main breaker. Very common in the ThroughFeed, as I said, this is more common than SubFeed lugs. So on ThroughFeed lugs, very common that you'll have one breaker that will be for the multi-panels. Yeah, if you're incoming from the bottom, if this is your incoming, we would put the breaker right here. But likewise, if you wanted to come in from the top, we would put the breaker here. And the other thing to note is the second connection is on the opposite side. So if your incoming cable is here, your connections from panel to panel that you'll need to make in the field are going to be at the top or the next panel. And if you had a third panel, then it'd be back to the bottom between these two panels. And that's the physical, the contractor will physically have to make those connections.
Todd, just for maintenance, if they will put a main in the second panel, can you guys make a main in the second, just to isolate that panel?
Yep, you could, yeah, exactly. You could have this ThroughFeed lugs
Just
here,
for isolation,
but main breaker here.
just to isolate that panel.
Yep.
The other one, can you flip the back? Where would the breaker be in now? On the top?
Here you can't put a breaker, just because you can't, because this is going to take two cables. So if you got a 100 amp breaker and a 100 amp cable,
Yeah, it's got from the switch.
You-
disconnect.
upstream, yep. So then you go upstream to the main switchboard, and that would have to be your disconnect. That's one of the reasons probably why this is not that common. physically that's how a through feed lugs. If you had main lugs, lugs bolted on one side, lugs bolted on other side, chassis of feeder breakers in the middle. Okay. As far as sizing, then panel board sizes are restricted only to the practical physical limitations, standard box heights, standard widths. This is probably the number one driver as far as box height, is that it is important to note that the NEC requires the operating handle of the topmost mounted device to be no more than 6 foot 7 inches above the finished floor. So whether it's the main breaker at the top or a main breaker at the bottom and the feeder breakers at the top, 6 foot 7 is the highest handle that it can be. Now, I don't know if you're a 5'1" electrician, if that's going to do you any good, but the theory is being you need to be able to shut that off at the top. Additional boxes and fronts required when the components required for one panel board exceed the standard box dimensions. This is just what we showed about ThroughFeed lugs, ThroughFeed lugs, SubFeed lugs. We get multi-section boxes for 84 circuits, 100 circuits, 128 circuits, no limit. And these again are just some of the industry standards. UL is a manufacturer's standard. NEC is an installation standard. NEMA provides the guidelines that all the manufacturers follow. They'll do a lot of instructions or maintenance procedures, things like that. Then there's some federal specifications out there as well. If you are doing work for a government facility, Department of Defense, or Human Services, or what have you, they'll often have their own specifications. So now, directly into the products. This is Eaton's offering of panel boards. So I'll walk you through how you would interpret all this general stuff we've talked about into specific Eaton panel boards. And I may say Eaton Cutler Hammer panel boards, just so you kind of know. Eaton is the Eaton Corporation is our company, parent company. Eaton Electrical is our business unit, and Cutler Hammer is the brand name of our electrical distribution equipment. So if I start mixing those three together, that's kind of where they're all coming from. To us, they're really all the same. So really there's two classifications when I'm thinking about a panel board. There's a lighting panel board, and I'll even further that one into lighting and receptacle or lighting and appliance panel board. And there's a power panel board. In an electrical distribution system, into your facility is going to be a main switchboard. It could be a 1200 amp service, 3000 amp service, 4000 amp service. That main switchboard will then distribute to more than likely a second level of what they call power panel boards. Maybe this is a 600 amp panel board that feeds 4 other panel boards. So this could be a case where it's a 600 amp panel board and it's got 4 100 amp breakers that feed 4 more panel boards. It's just a convenient means to distribute power, again, more efficiently. Because if I've got my main switchboard here, and I've got a bunch of lights and receptacles I need on the other end of the building, rather than feed all my loads, I run one set of cables, large cables, to a big power distribution board. From there, I can take her one step down into my lighting receptacle or individual load type panels. So our lighting panel boards, or lighting receptacle panel boards, are on the left. That's the power line 1A, 2A, and 3A. We also recently added a 3E, which I won't cover here, but it fits right in. It's the same type of thing. And our power panel boards, or power distribution panel boards, are our power line 4 family, or power line 5. See, there's a 4B and a 4F. Anybody got an idea on what the 4B and the 4F might mean? F, fuse, I heard that. F for fuse, B for breaker. What's better, breakers or circuit breakers or fuses? Gotta make this. Circuit breakers. Less heat loss, less wasted energy. Resettable. If you get a fault, whether if you're a contractor and you're trying to install this and some wire was running and it keeps tripping on you and you just keep having to reset it and use it to finally track down your fault and then reset it and you're good to go and you can walk away. You got a fusible switch in there and you get a fault or maybe a couple faults while you're starting up. Every time you get a fault, you got to grab and say, oh, $50 fuses, $50 replacement fuses, $50 replacement fuses. So with that said, ground fault is another reason. If you need ground fault protection, circuit breakers provide ground fault protection capabilities. Circuit breakers give you the ability to move that trip curve and coordinate your entire system so things trip in the proper order. Now, what do you suppose we manufacture, circuit breakers or fuses? Space, also, we'll touch onto that, but space is another consideration. So this, when this presentation gets posted, this is one of the pages that I would probably suggest when you're doing your designs. This is what a manufacturer is going to look for in a panel board. When you say, give me a panel board, how much? I'm going to say, well, what's your voltage? What's your frequency? What's your main amp rating? What kind of main do you want? Main lugs, main breaker, main fusible switch? What's your short circuit current rating? And a big factor in, number one, safety, making sure the panel is going to self-protect itself and not explode on the wall, also drives the cost pretty substantial. What do you need for branch circuits? How many breakers? What's the type? 1 pole, 2 pole, 3 poles? And how many amps? 20 amps, 40 amps, 100 amps? What's the environment? Mentioned earlier, what if, you can assume I'm putting a panel board in the wall, but we don't make all our panel boards for putting them inside here. You may want to put the panel board on the outside, in which case you'd need a NEMA 3R enclosure. Did you talk about enclosures yet?
We know the wet location and dry location.
Okay. And from our standpoint then, NEMA 1 is the lion's share of what we do, mounted in a indoor enclosure. NEMA 3R mounted outside. NEMA 3R for a panel board is the good thing to remember is NEMA 3R rating is only prevents intrusion of water coming down from the sky. It doesn't prevent intrusion of water from a guy with a hose spraying the bugs off. That's not what it's for. And you need to move into a different step. So when you put a panel board or even a switchboard outside, there's other precautions you should take along with a NEMA 3R type rating. NEMA 12 is another common one. NEMA 12 is dust type. Maybe not necessarily in a commercial building, but if you think about a lot of manufacturing buildings, you've got processes that there's always some kind of fine film in the air. And we talk about the life of electrical equipment, 40 years, 50 years. I can also tell you, well, the life of this electrical equipment is 8 to 10 years because your facility has got all kinds of stuff in the air. There's water, large temperature fluctuations. There's little dust particles in the air from the process. I don't maintain it. I just plug it in, and then when it blows up, it's done. And there's all kinds of things. If you ask me, how long is my electrical equipment going to last? I'm going to have a list of questions, and I'm going to say, well, it's going to be affected by these things. Could be 8 to 10 years, could be 50 years, could be 100 years. Last thing on the list is fully rated or series rated.
Todd, before you move here,
Yep.
I always like to mention the service rated panels, you're gonna throw a couple, because the same panel
Yep.
could be used anywhere, but if it's a service has its own requirement, you're gonna say, I don't know if you're gonna mention somewhere else. Oh, this is a specification for.
Yeah, this is as good as any. In a panel board or a switchboard, NEC actually has part of the code specified as service entrance equipment. When the utility hands you the cables and says, here you go, power your building. And your first piece of equipment may be a panel board, it may be a switchboard. That first piece of equipment that you're terminating to, considered your main building disconnect. This is how you shut off power for everything that you're feeding. That piece of equipment needs to be designated as service entrance equipment. And that includes a sticker on the front of that gear that says service entrance equipment. We have to put that sticker on in the plant by NEC code. You can't just mail you a sticker and you can slap it on. Well, in theory you could, but if the UL inspector found out about that, he would not be happy. So we need to actually do that in the plant. And the one thing we do, other than the sticker, is to actually put a removable neutral to ground link. So you'll have a neutral wire coming in, so you'll have a neutral bus bar in a 4-wire system, and we'll provide a copper bar, a bolted connection between the neutral and the ground. And if you guys talked about grounding, think about the grounding, then everything downstream, you know, you're tying your neutral and ground together.
This is the main bonding jumper between your neutral and your electrode grounding or grounding electrode conductor. So that's very important.
And as a user, if it's your building, you'll probably never need to look at that, touch that, or even know where it is maybe. A utility company, I believe, that's probably the driver behind it. They may be the ones who need to come in and change something or remove that for some reason. In service entrance equipment, what do you suppose the reason is behind this having to have some kind of service entrance equipment label on it? It's going to shut power, but who?
The fire.
The fireman. Number one reason, and this is when you build a new building, the fireman's probably going to walk over and the inspector's going to check it, and the fireman is going to look and say, where's your service entrance equipment so I can shut off power to your building when, you know, stuff hits the fan.
So what would they just go to the disconnect out there, the meter socket, shut it down from there if they needed to, come in? You know, I mean, you had that switch on the meter socket too.
It's not rated as a disconnect.
Oh,
It has to be rated as a disconnect.
Correct.
I don't
Now,
think
you can do service entrance equipment outdoors,
with the,
but you probably have to have that discussion ahead of time.
you have, what's he talking about, this bypass, that you take the meter and you bypass the meter just for service?
Oh, yeah.
That's meant for bypassing the meter, taking for service, not to disconnect the building, at least the way I
Yeah,
understand it.
yeah, that's for, I need to pull the socket
Yeah.
out and put a new socket
Yeah,
out. Like
so-
recently, most people, you had the electrical mechanical meters with the dials and stuff, and I think they went out and slapped those up and put the new solid state one in, or digitals. So pretty much that's all that's for. Yeah, this is, in there's, I don't think there's it's not really a pure safety service entrance that you can lock out, tag out, or anything like that. Short circuit current rating, talked about the short circuit, available maximum short circuit in a facility, that all the devices have to be rated to handle that maximum short circuit. So from a panel board standpoint, short circuit current rating is a combination of the rating of the bus, and that's the maximum voltage fault current that the chassis can withstand without damage. And that's classified as withstand when you hear the words withstand. It pretty much means what it sounds like. It's the ability to sit there and withstand that much current without damage. The interrupting rating of the overcurrent devices, which includes the main and the branches, and that's the other part. Each individual circuit breaker is going to carry a short circuit rating stamped on the label. We might have a couple different ones depending on the voltage, but it will be stamped right on it. So you want everything. You want the panel board, bus, and chassis to stay in one piece under a fault condition, and you want the circuit breaker to interrupt the fault. And when all is said and done, everything should be turned back on, put back into operation without damage. Asterisk, except for the location where the fault actually occurred. So if your fault occurred inside your panel board, you might have some auxiliary damage, cables and stuff inside there. And generally, the lowest rated device will determine the overall rating, which I'll come back to. That'll be the difference between fully rated and series rated. Oh, which it happens to be the slide. So, fully rated device or fully rated panel board means all the circuit breakers, the fusible switches inside that panel board are rated for the full perspective or the maximum short current circuit at their terminals. So the maximum available fault current is what all your circuit breakers are going to be rated. Series rated is a value engineering or more cost-effective alternative than a fully rated system, because in a series rated system, short circuit interrupting rating is assigned to a combination of devices, the main breaker and the feeder breaker. And it could carry through also the main breaker and all the feeder breakers, main breaker, feeder. That combination of devices is going to carry the short circuit interrupting rating that is required for the panel board. So that's the maximum available at that panel. And how do we do that? Basically, we take the two circuit breakers, the main and the feeder, we put them on a bench test, we inject them with the current that we want, and we are saying one of those two breakers were tripped. We're not going to tell you, or we don't care which one. So if one of those breakers tripped, take your panel board offline in the event of a fault. Why this kind of makes sense is if I have a 65,000 amp available maximum fault current at a panel board, then my main breaker is rated 65,000 amp, my feeder breaker is rated 65,000 amp, everything else is rated 65,000 amp, and therefore the insulation in the circuit breaker and the beefiness of the circuit breaker is for 65,000 amps. Now a series rated allows you to use your 65,000 amp main breaker with, for example, 10,000 amp rated feeder breakers. So my feeder breakers might only be rated to handle 10,000 amps, and therefore they've got 10,000 amps worth of insulation and cost associated with it, and obviously they're going to be cheaper to make, cheaper to sell, cheaper to install. But by series rating this, we've put these two breakers on a bench at UL and guaranteed that one of those two breakers will trip and take the circuit offline and protect the panel board. So visually, this is what I was talking about, 65,000 amp main breaker, 65,000 amp feeders or branch devices. In a series rated panel, same main breaker, but 10,000 amp feeder devices. It's also good to note that your main breaker doesn't necessarily need to be in your panel board. If you wanted to use main runs only and save some money, and this main breaker, quote unquote, is actually in the switchboard upstream, that is still acceptable. That is valid. I kind of threw out the giveaway answer, but why do you suppose this is the best way to do it? Cheaper. Cost effective. Cheaper for us to make, cheaper for you to buy, cheaper to sell.
What wire would you use on the right side there for feeding it?
For the load,
Well, yeah, like, I mean, if you're coming in with 65K and then you're going to 10K each one, would you size them all in 10K?
well, keep in mind when you're sizing wire, this is the maximum available fault current. So this breaker may be a 200 amp. I just do that. You and your technology. So when I'm sizing this breaker, I'm sizing it to the continuous current carrying required. How much current am I carrying? If I have a 200 amp panel board, all the wire upstream is going to be sized to 200 amps. It's not going to look at this number.
Because that would be the service entrance.
Yeah, this is the withstand capability. So I don't believe there's any wire that looks at these two. There may be, but
Let me just jump in. Unless you do
Okay.
medium voltage, when you size wires, you don't look at the short circuit. Unless you do medium voltage, higher than 600 volt. When you go higher than 600 volt, 13 amp and 1247, then they start sizing the conductor based on the short circuit, which is really weird. Not weird, but they start looking at these numbers. But for sizing conductors, for up to 600 volt, you don't have to worry about sizing conductors. You only worry about the actual load, if it's continuous or non-continuous. Only when you do medium voltage, you start sizing based on the short circuit. Which series rated, it doesn't mean anything in medium voltage. Sorry.
yeah, that's true. And it really doesn't mean anything in a switchboard construction either, unless you're just using the feeder breaker and the switchboard to feed a main lug only panel. So this is strictly for panel boards. And it's strictly for cost. And cost is pretty important, obviously. So again, series ratings, these are tested combinations, breakers or fuses. We publish them, or all manufacturers publish them. So you can't just take any two breakers. You have to look at a chart and say, I can use this breaker, feeder breaker, with this main breaker up to this amount of fault current. Upstream overcurrent device always has a higher rating than the downstream device. But think about it, you only need to buy one upstream device. You're buying multiple downstream devices. Upstream device may be mounted in the panel board or further upstream at the next place, whether that's a switchboard or what have you. And these are the two acceptable combinations of a breaker feeding a panel board or a fuse feeding a panel board. And every time, well, it's just a visual here about what it looks like here. Main breaker, UL labeled as series rating with your branches, or this is where you have the main lugs only in your panel board. This is all cable that feeds upstream. This breaker will be actually labeled with all these feeder breakers here. This is just kind of a generic snapshot to show you why people look at series ratings or consider series ratings. How much money am I actually going to save? Is it worth it or is it not worth it? Because you got a lot of people who say, I don't trust series ratings. You know, even though us and UL are putting all the forces of electricity behind it and everything we do behind it, a lot of people, not good enough. I'll only take fully rated systems because that's all I'm comfortable with. I want all my devices properly rated. Well, we can say, well, that's fine, but between us and UL, we're telling you that electrically, your system will work just fine. Nothing's going to blow up. Everything is rated to carry the fault current that you're putting into your system. And if you go to series ratings, you can save a little money. In this case, pretty much the one line we just showed, 225 amp main breaker, 65,000 amps interrupting. So when we're looking at pricing the system on a fully rated system, a main breaker, 2,300 bucks. All these feeder breakers, which all have to be rated 65,000 amps, add up to about a little less than $10,000. If I go series rated, I've got the exact same main breaker. Remember, that has to be carries the same rating, so that's 65,000 amps. Same price. Now I can use a different feeder breaker. And this is where you're going to save money, because these are my 10,000 amp rated feeder breakers. And adding up, these are 625 bucks a piece. These are 245 bucks a piece. So with all those feeder breakers, I went from right around 10,000 to right around $5,000 for my panel. And that's when the owner says, "Really? Well, let's do it. Let's look at, maybe not my whole facility, but let's look at all these panels over here, and I'll take my 5,000 bucks and, you know, spend a weekend down in Vegas or something, whatever he wants to do with it." This money talks, as long as you're not sacrificing anything. A lot of times you're going to do trade-offs. You're going to pay less, but you're going to get less. And here's one where, in many cases, you're getting the same. I'll say that in many cases.
And Todd, just let me inject one little thing, guys. Series rated is a great application for receptacle panels, lighting panels. You would be, I mean, you got to use, it's a great idea from an engineering point of view to use it in lighting panels and receptacle panels.
Yep.
Now you have a panel that feeds the majority of the panels are motors, obviously. That's a good application where air handling units and chillers and all this stuff. That's your good application where you have to almost have a fully rated system. But all your receptacle panels, correct me, Todd, if I'm wrong, all your lighting panels, almost always series rated, specified. That's a great application for series rated. And am I missing anything for lighting panel, receptacle panel, small appliances panel maybe?
No, you're, I mean, you pretty much hit it. There's a, if you read the fine print, or if you start to get into this, there are restrictions if you have a high load of motors. Or if you have any motors of size, if you have more than one motor off the panel board, probably don't look at series rating. But lighting, receptacles, definitely look at it to consider. There's one trade-off as far as coordination. When I say coordination, I'm talking about tripping. Which trips faster? Okay, you've got a main breaker and a feeder breaker. And the three methods of coordination are series rated, okay, where I can't tell you which one is going to trip. I'm just going to tell you that one of those are going to trip. And if you think about it, if I got a bunch of branch devices under my main and I'm series rated and one of these trips out or my main trips out, if my main trips out, everything else is going down. Okay? So you have to have an installation where that's fine. It's not going to hurt you if it's just lights or receptacles, and I don't lose any computer loads or anything like that, no big deal. Fully rated system, you've got a main and the same feeders, or higher rated feeders. There's no promise that this one is going to trip before this one, but over a lot of the time it will. And when I say a lot of the time, I will say low-level faults. If you think about an overload condition where you're just plugged in, or a very minor fault, there's a good chance your main is going to trip first. Your feeder breaker is going to trip first. Your main later, or only in a high fault condition, major fault, that may trip first. So it's a little bit more reliable in that you've got a greater chance that your branch is going to trip, keeping the rest online and power going through it. The third method is selectively coordinated, fully rated. Okay, so everything is fully rated to handle the short circuit current, but selectively coordinated, and this is defined in NEC, which means over any fault, overload, medium fault condition, three-phase bolted fault condition, worst case scenario, my branch breaker is going to trip first, my main breaker is going to trip second. NEC mandates selective coordination under for a few installations. Anybody think of one? Hospital. Number one by far and foremost, hospitals under, there's basically everything that feeds the emergency essential equipment, which is your critical branch. And if you do hospitals, you'll see this, this will be part of how you're designing it. We'll have a critical circuit branch, a life safety branch, and an essential electrical equipment branch. And in those cases, you don't want to shut the power off to the ventilator when, you know, because somebody put a screw in the wrong receptacle hole or something. There is other places in the code. An example, one of the things they did, and I think it was the last code cycle, was any place that is designated by the government and the municipality as a critical operations.
The cup system.
Cups, yep.
Cups.
Yep. And
For national security places that are designated by government, national security, financial, military, they have to have coordination too.
yeah, and we haven't seen this yet, but if you read it, it could even be as simple as if the municipality designates the local school as the emergency shelter, well then
It could be.
your entire school, which probably could usually be built on a $100,000 electrical budget, now may cost you $150,000 because you got to do selective coordination. And when we talked about costs, series rated was half the price of fully rated. Series rated is going to save you money over fully rated. Well, if you want to go selectively coordinated fully rated, you could very easily be double of that one. So you get what you pay for. You pay more, but you're going to get the reliance or assurance that you're fully coordinated.
So the series would cost you more if you need to have emergency lighting, light coordinating with it or whatever?
Well, if you go series rated, you cannot selectively coordinate.
Oh.
You're restricted to a flip of the coin. And that, you have to completely understand that if you go with series rated system, that in this application of this building, I cannot tell you which is going to trip my branch or my main. For $5,000 in your pocket,
Where would you get
have
it?
to
Just in a general warehouse?
a general warehouse, yep. Think about well, even a school. If it's if you're just yeah. If you're a normal classroom like this, I don't know, there's some electronic equipment on here, but I don't think if I went and turned that main breaker off, we'd probably sit here for a minute, I'd turn it back on and nobody would know anything. No big deal. But now if I had a maybe I had some sensitive electronic equipment where if I turn it off, turn it on, maybe I've got a half-hour reset process, or I got to call down to the main desk to have them reset it, and all of a sudden I spend 5 hours or 2 days getting the thing back up and running, and it costs me money somehow. Then you want to stay away from it.
Chad, what about the room for first quarter where we have all those different plugins and stuff? Is that series rated too? You know, where it's like
First quarter.
480.
Up to my knowledge, all these lighting panel, receptacle panels, they're series rated because it's cheaper. I doubt that they've done
motors lab and stuff.
I believe so. I have to check the new one in the motor lab. But I believe so. All that we do, unless you really have to have fully rated system because of the code. Lighting receptacle panels has always been 10K and series rated.
It's like really big equipment in the motor.
I mean, I'm not sure how much that particular one is.
Yeah, if you got a lot of motors off that panel you're talking about,
But I just
maybe
want to
not.
remind you that these motors are lab motors and not loaded. All the stuff that we did there, they're just
One of them draws 90 amps still unloaded.
in rush.
Yeah.
In rush.
I think so. It's a lot
Yeah,
still.
in rush. But these are small motors that we use them in the lab. I know what you're talking about. They're not loaded. They're not running an air handling unit, or they're not running a pump. So.
Okay.
How are we doing with time? I think we're We usually
Okay.
break for lunch. You have good stuff. Do you mind if we do a quick break for lunch? What's your time?
Yep. Let me.
We'll feed you too.
Let's.
Or
Yeah, I
choose the
just
right
got. I
moment.
think. I think I'm almost. Well, let me
Choose
see.
the right moment for
Okay.
you to break. Just to remind you. Otherwise, they'll start throwing things at you here.
All right.
And we'll take half an hour break, guys, and we'll come back. Do you have time? I know we have a few other good
Yeah.
stuff that you will do. We'll
Yeah.
come back and we'll make it Cutler Hammer Day. Okay?
Okay. Give me. Yeah. Give me. Let's see. Well, I already
Take
talked
what you-
about that. This is the one thing I want to mention on series rating. You will get a book like this in the panel board. So when you open the front door and you're going to see the directory where you're labeling your circuits, this will be there, and inside that book will be the listing of these circuit breakers. Keep touching
It's
that
a
screen.
smart guy.
Those circuit breakers need to be installed to meet the series rating of the panel board.
And by code, you have to label the panel as series rated too.
So I guess this is either now or I
Good time?
probably
Okay, so we
10
guys
minutes.
have half an hour, please, quick. Eat something and we'll come back. We talk about switch gears after that. We'll come back.
Yep.
Check it out. So the, yeah, one that you're talking about, like